This video is going to go over day 2 of solving differential equations. So this is in your packet on page 27, and the first example asks us to find the general solution. So think about what you have to do first when you're asked to solve a differential equation. If you notice, we have x's and y's all mixed up, so we need to make sure we get the x's with the dx and the y's with the dy. And we have to make sure we're using correct algebra. So these two things are being multiplied. So I could multiply both sides by dx to start. And I'll have x squared plus 4 dy equals xy dx. Okay, and then I need to get the x's to one side, and I can't distribute, because if I distributed x squared dy plus 4 dy, I'm not going to be able to, it's only when they're products can we divide and get them to the other side. So I have to divide by that entire quantity of x squared plus 4. Now you can do this in a couple steps. Some people might do the one step because they might look at it and say, okay, we also need to get rid of the y. So we can divide both sides by y. I just have to put parentheses around that x squared plus 4. That'll give me dy over y equals x over x squared plus 4 dx. That's called separating the variables. And if it's an AP free response question, you don't get any points if you don't do that first. So that's very important. Okay, now we can integrate both sides. When we integrate 1 over y, we get ln, the absolute value of y. On the right side, U substitution will work. We need a 2, but we need to balance with a 1/2. Okay, once we get to this point, we have ln absolute value of y equals 1/2 ln the absolute value of u, or x squared plus 4, plus some c value. I'm going to call it c1. Now there are a couple things we can do here. We want to eventually solve for y, and if I exponentiate both sides, this 1/2 is going to cause me problems. So I'm going to make that 1/2 be the exponent. I'm going to use the property of logs, where it's ln of a to the r equals r ln of a. So I'm going to take that up. Now, I don't really need absolute values because x squared plus 4 is always going to be positive. So that's going to turn out to be x squared plus 4 to the 1/2. Now I can exponentiate. We want to be careful when we exponentiate. This becomes our entire exponent. I know the e to the ln of the absolute value of y. The e and ln are inverses, so they cancel each other out. Here it gets a little tricky. And this is where students tend to make a lot of mistakes, because we have to use the properties of exponents, which you have e, if you have e to some sum, before it was combined, it had to be e to one term times e to the other term. So now think about it. If you have two bases that are the same, you add the exponents. So we could go backwards. Now when we do this, e to the c1, I'm going to make bc. And I can remove the absolute values because e to any power is always positive, so y is never going to be negative. The e and the ln will cancel, and I just have the square root of x squared plus 4 times c. And that's my general solution. Okay, so go ahead and try the next one. It looks very messy, but you want to think about separating those terms. Getting all the x's with the dx, all the y's with the dy. The first thing, hopefully, that you're doing is separating the two terms. So if I divided just by e to the negative x squared, I'm going to have e to the x squared times xy dx with that negative out in front. I know I need to get rid of the y. Once everything's separated, we can integrate. We need to think about how we can integrate each side. Hopefully you're thinking monomial division on the left side. You know what, when I brought that e to the x squared, I don't know why I put a negative there. Let's change that. That negative was out in front, but it's not with the x squared, so I don't have to have a negative. So this negative is going to pull out in front. So let's just make sure we have the same thing up to that point. This, when it went to the top, the exponent went away, which I wrote it that way, but then down here I had included a negative. So just make sure you have that as a positive. Okay, and then you get an answer like this. Well, this isn't how they'll want us to keep the answer, but we can think about what we can do to make it look a little cleaner. One thing we can do is multiply the whole equation by 2. Now 2c1 I'm just going to make c. I'll make that just to make it a little bit more simpler. The exponent, I can lose the absolute values because that squared will always make it positive. I'm just going to let 2c1 be c. Now at this point we can't really solve for y at all, so this may likely be how they put that general solution. They may bring this over to the left side and have it equal c. But this one wants us to go on because they gave us the ordered pair 0, 1. So we're going to put 1 in for y and 0 in for x. ln of 1 is 0. E to the 0 is 1. So our c value is 2. So that specific solution, I'm going to write it as y squared minus ln of y squared equals negative e to the x squared plus that c value of 2. And again, one of the things that you may see them do with this one is write it where you pull everything to one side and let the right side equal that c value. So that would be